Hello everyone. Today I'll be presenting our way to surf in the chemical space and to chart those regions of chemical space that contain synthesizable molecules and the molecules that indeed can be delivered, not just ideas, but really the molecules. And that's related to enamine, which I'm serve as a scientific advisor at, and it's tremendous knowledge that is transferred into the enamine make-on-demand compounds. The chemical space is vast, and really it's something that unbelievably can be generated, and commercial availability, we're talking about really tiny portion of the chemical space. So that's approximately 8 million in stock items and trillions of make-on-demand compounds. And those make-on-demand compounds has been a really great and useful alternative to the in-stock set, and there are a number of applications of the make-on-demand compounds in virtual ligand screening, DLML approach, and SAR by catalog. When people work with make-on-demand compounds, they should know, and they probably experience that, not all make-on-demand compounds are useful or can be synthesized and eventually delivered to the lab. So the reason is that the synthesis is very often a bottleneck of make-on-demand compounds. And this is because some reagents or building blocks are not really available, and maybe even incompatible with each other. So the additional research is necessary to come up with the right synthetic approach to couple them, as well as the procedures that are typically taken from the literature. They may not be applicable to those reagents and building blocks. So all this actually causes a long lead time to deliver the compounds and their really low deliverability. And obviously, this is something that really makes us unhappy, because when we select the compounds from trillions of make-on-demand molecules, obviously we perform a pretty thorough selection and come up with a set of maybe 100 or few hundred, as Marcus just mentioned, those who really we want to be synthesized and screened in the lab. We think that quality of make-on-demand compounds is actually in chemical expertise, and this expertise is something that is made enamine famous, because it hosts over 1,000 scientists, different scientists, who use and who generate that chemical expertise and basically use it and reuse it for their projects. And this tremendous chemical expertise that's been generated for more than 30 years allowed a company to synthesize over 4.1 million molecules. So the expertise is actually the basis of enamine make-on-demand. And there are two things that we use when we basically generate enamine make-on-demand molecules. One thing is validated synthetic procedures, only validated synthetic procedures, and the second one is obviously this procedure should be validated with enamine in-stock reagents. When we perform the selection of the reagents, we select only those reagents that reveal high score in the reactions and are able to generate large chemical spaces. And that's just an example that illustrates the selection of aldehydes for the reductive amination reaction. And as you can see, the aldehyde on top is actually, we call it high score aldehyde because it's been tried in a number of reductive aminations, and the success rate for this particular reagent is pretty high. So we include this reagent to enumerate enamine make-on-demand compounds. For this aldehyde, on the other hand, we see pretty low success rate. So we rather keep it from the enumerations, but still can use it for the custom chemistry projects. We typically validate as many options for the reagents and for the procedures as possible. And when we see that that the reagent behaves has basically low success rate in one procedure, we try to substitute the procedure and test the reagent again. When we see that even with the new procedure the success rate is pretty low, then we typically exclude this reagent from the enumeration. And yeah, the enamine make-on-demand is growing, and again, as Marcus just mentioned, the growth is substantial in the past decade, despite all the things. And the expansion of enamine make-on-demand is through the addition of new reagents and new synthetic procedures. And what we also do, we not only add new reagent and procedures, but we thoroughly keep the list of the reagents and the procedures in that way that only high successful procedures and the reagents are included. All this allows us to keep high delivery rate of enamine make-on-demand compounds, and that's over basically 70%. Few words about the basically types of the compounds that we offer. Most of you are familiar with the real compounds, which are the screen compounds we provide, and we also have a set of make-on-demand or made building blocks available for search and basically purchase. All these products are searchable through different ways, including the online search through ChemSpace, and I'll talk about it a little later. So just a few words about this make-on-demand building blocks and real compounds and what the difference and the features of both. So make-on-demand building blocks or made building blocks are really good for fast SAR by reagent, and those are building blocks or analogs of the in-stock building blocks available at enamine, and they're typically synthesized in up to 5 synthetic steps from in-stock available reagents. They're typically synthesized on a gram scale, and the chemistry that is used to make them is actually typical flask chemistry. We have published a few papers related to these building blocks, and that's rather old manuscript, and we definitely need to update it. A current version of make-on-demand building blocks, which is over 770 million molecules, includes all the classical functional derivatives, and they are really good tool to again to perform SAR by reagent. As for enamine real compounds, those are final molecules that are typically synthesized in a one-pot parallel chemistry fashion, in 1 to 3 synthetic steps from the available reagent, and the amount that is synthesized is typically a milligram scale. So they're typically ready to put in the plates and perform the screen. We have published a number of papers related to the synthetic approaches to the real compounds, and those are just some of them. There are debates on the terminology of the real, and this is just a simple explanation of what it is. So there are few types of the real products. One is the database, which is an enumerated file or file set of files, either in SMILES or SD format. And the database that we typically offer, that's a public database, which is available from Enaminet or direct download from FTP site. And we also offer a real database as a full set. That's an enumerated set, and available for download again as SMILES, not SD files. Sorry, because it's too large. And the latter set contains over 33 billion molecules. Then we have real space, which is non-enumerated syntons or fragment based space, and it's available through Biosolve IT's Infinity or Spacelight tools. We can also generate the custom spaces, again non-enumerated synton based, that also can be searched through Infinity. Just few words about the difference between the database and the space. So when we create the database, we're still trying to focus on lead-like chemical space, and we use the restricted combinations of reagents during the enumeration. The synthetic feasibility is over 80%, and the molecules are typically synthesized within 3 or 4 weeks. The space is larger in size, and there is no restriction to the coverage. So you can find molecules as large as 700 Daltons in the space, and the feasibility for the space and for database is pretty much the same. You still can get the molecules with with over 80% within 3 or 4 weeks. The enamine make-on-demand products, both made building blocks and real compounds, can be accessed through the direct download from FTP or cloud. They can be searched online at chemspace.com using all the classical search options like exact match, substructure, or similarity. You can also use Enamine Store for accessing enamine real compounds, not the made building blocks, at least not yet. You can also access these compounds through ChemSpace API or KNIME nodes we specifically created for searching in such huge chemical spaces. You can also access the whole enamine make on demand via punch-out integrations with ChemSpace, or again, where BioSolidity's Infinity and SpaceLight tools. These are just a few papers that use real compounds, and again, I won't stop on them, but again, there are just few of them shown. But it also, worth mentioning is that we've recently published in a collaboration with BioSolidity, with Crystals First and Professor Kleber group, really interesting approach that combines crystallography, chemical biology with virtual ligand screen, and basically applies this to huge chemical spaces like enamine real. This study is something that really shows great combination of the tools, and we're looking forward to expand it. As I mentioned at the beginning, chemical space is vast, and we're working in a very small portion of it, and obviously we try to expand it as much as we can, basically every day. And if we're talking about enamine, the company works hard to generate more and more experimental knowledge by producing over 2,000 new building blocks and over 20,000 new screening compounds every month. And this is something that again is used to expand the chemical space of real compounds and made compounds. What we also done is we used this data, kind of real data, and apply it to non-real reagents. And that's something that we've just released, and it's called Freedom Space. That again, that is mentioned. This is the product that we create together with enamine. And we use their knowledge, their basically knowledge on reagent and reaction statistics, and we perform the machine learning assisted classification of the reagents to apply this knowledge to the reagent that are not in stock at enamine, but from other suppliers. So with that, we're able to enumerate over 5 billion molecules of Freedom Space 3.0, and we expect pretty much the same synthetic feasibility as for the real compounds. This Freedom Space 3.0 version is a really good addition to enamine real space, because it expands the real by the addition of non-real reagents. And we would be happy if you try it out either on ChemSpace, or you can download it as Smiles, or again you can use it in Infinity and SpaceLight tools. With that, I would like to thank you for listening to me today, and I would like to thanks to all the teams at enamine, ChemSpace, BioSolidity, NextMove, Crystals First, our academic collaborators from all over the world, and obviously our armed forces that allow us to work safely and provide you with more and more useful molecules. And obviously, I thank you to everyone who explores enamine make on demand. And I would be happy to take any questions.